Hello children, how are you all? Hope you all are fine and doing well, and hope your preparation is going very well. So many of you, I know that you are doing a very hard work, putting a sincere efforts, towards your goals. Many of you are preparing for a mains, many of you preparing for a NEET, I know that. And many students have this one. Yes, when it comes to the physics, of course many people will be saying yes, physics is a subject which decides rank either in NEET or mains, children. So I'm very glad to inform you all, to share with you all that children, this is our new channel. Already we have Physics Plaza. So there we covered 9th and 10th concepts actually. Of course there we try to even upload a class 11th 12th also. But many of our students, I can say, who are a strength of our channel, so they suggested that, sir, why don't we have a special channel like class 11th 12th only for pure mains and NEET. They suggested, children, yes, as per all your suggestions, as per all your support, yes, now we are we started a new channel, and this is the first video in this new channel, Physics Plaza 2.0. Children, in this channel exclusively we are going to cover the concepts of class 11th 12th mains and NEET concepts only. So our idea is, first will be, of course, simultaneously 11th and 12th will be taken, and again I'm telling you children, here we will be covering the mainly concepts along with the numericals also. Yes, for each and every chapter we cover concepts, maximum numericals are covered, numericals from S.C. Verma, from Singage, D.C. Pandey, like all whatever the standard reference books are there. So from that we are going to cover all related numericals. First we upload the chapters like topic wise, then one short video, then numericals will be uploaded. Okay children, so hope this channel is going to help you all for your preparation. So we are very thankful to you all for the support given to the Physics Plaza. So hopefully expecting the same thing for these children. Yes, this is exclusively for a mains and NEET only. So our humble request is that, yes, make a use of it. So whenever the class are taken, just kindly have a notes and a pen with you so that you can take some notes. And any doubts, if you can get in between, just you can put in a comment box. Yes, especially we will, children, we are very much particular about the doubts asked in a comment box. Yes, maximum within 24 hours or maximum 48 hours, children, just we'll try to answer all your doubts, children. Okay, so once again we are very happy that we are with you with a new channel, Physics Plaza 2.0, where we are going to cover mains and NEET concepts. So in this channel, children, first we thought which chapter we have to start, whether a class 12th or a class 11th. If it's a class 11th, what chapter should we take? Because we are starting one chapter means, so that should be a very important, and that concept should be there in all chapters, and every chapter should use those concepts whatever we are learning in the first. So like that we thought, then finally we came to the conclusion, yes, let us start our concepts with the mechanics. Dear children, first we will be starting the concepts of mechanics. Then you may get a one doubt actually, sir, either in class 11th or class 12th we don't have any chapter like with a name called mechanics. Dear children, mechanics is not just a chapter name, it is one of the important and basic branches of the physics. In a physics we have so many branches like waves, oscillations, thermodynamics, electricity, optics, electromagnetic waves, electromagnetism, electrostatistics, like this so many we have. But one thing, you can't imagine, you can't understand all these chapters without having the knowledge of mechanics. Then you can understand how important a mechanics is. In the simple words, children, mechanics is like it's a soul. It is just a basic of entire physics. If you can get a command on mechanics, yes, you can do the best with all the chapters. Even, when you will be learning, yes, you will realize this point, children. When you will be learning all the chapters, might be from class 11th or class 12th, children, you will be finding somehow, directly or indirectly, the concepts of mechanics you will be finding in each and every chapter. And indirectly, knowingly or unknowingly, you will be applying the formulas, concepts, and applications of mechanics in each and every chapter. So with this we can understand. So what I'm trying to say, once the moment you can understand, the importance of what we can say of mechanics, then you start respecting. The moment when you start respecting, you fall in love with the mechanics. So once you can fall in love with the mechanics children, yes, you get, you can enjoy that mechanics concepts, and obviously it leads to the, to enjoy all other chapters in a physics, and definitely you can, do the best in a, whatever the exam which you are going to try it out. Fine, then what is mechanics children? So mechanics is all about the study of the motion of an object children, in a simple terms. So in entire mechanics, we will be studying about the motion of an object only. Children, mechanics, broadly classified into two groups actually. So here mechanics, if you can see, yes, as I told you, it is the study of motion, and it is divided into kinematics and dynamics. Then what is a kinematics and what is a dynamics children? So kinematics is all about the study of motion. Then you may get doubt, sir, you said mechanics is the study of motion, then kinematics is the study of motion, then what makes the difference? Yes children, so there is a difference. Look at here. So in a kinematics children, we study the motion but without knowing the cause. This is very, very important. Very important. Which means what here? We are not bothering actually. For suppose, if an object just started moving, we don't think who is the reason for that actually. Just we only will think what is the distance covered, what is the displacement covered, with what speed or with what velocity it is going, what is its acceleration. So what is the relation between all these parameters? Children, these parameters, distance, displacement, speed, velocity, acceleration, these all are called kinematic parameters. How these all are related. So all these things we will be discussing in kinematics, but without knowing the reason. Only we, speak and we study about the terms, some parameters related to an object which is in motion. Is it clear? So in a kinematics, strictly we will be discussing about a motion of an object, but without knowing the cause, without knowing the reason. This is very important. And if you can see this kinematic word children, kinematic, clearly kinematic, okay na? So this kinematic is derived from like this actually, kinemo plus matics. Kinemo children, it is derived from a Greek language. The meaning of this kinemo is a motion. Matics means it's like a maths. You may get one doubt, sir, what is this maths in a motion? Yes children. So if an object is a moving children, we should be able to calculate its distance. We should be able to calculate its displacement, velocity, acceleration. So many kinematic parameters will be there which are related to the objects which are in motion. Yes, to calculate that, we need a concepts of maths. So concepts of maths we are going to apply to the a body which is in motion in a kinematics, so that only we can get a complete idea, complete concept about those bodies which are in motion. Children, let me tell you here, if our body is like a physics, what we can say, so blood is there, you can compare with the math. Okay, so our body is like a physics, then blood is like a maths. That important, that much importance. Then a NEET students may get doubt, sir, what about us? So it's maths means not a pure, depth maths. It's not a applied maths children. It's a simple, basic concepts of maths. Yes, definitely we will be covering the basic concepts of what we can say maths, a special video. So don't worry, it is useful to you all. So math means, again I'm telling you, it's not applied. It's not a high standard maths. The minimum maths, whatever you learnt up to 10th, yes, that is enough here. Okay, na? So in a kinematics, purely what we'll be doing, we'll be talking about the motion of an objects without knowing the reason, and where we'll be applying some math concepts. Okay, fine. And come to the dynamics children. Yes, here we will be studying the cause of motion. So in a kinematics, we studied the motion without knowing the cause, without knowing the reason. But whereas in a dynamics, we will be studying the cause. What is a cause children? Yes. See, already we studied, right? In your class 9th, class 10th, class 8th, we studied. So what is that external cause which will try to change the position of an object, which will try to bring the object from rest to motion, motion to rest, which will try to change the direction of what we can motion of an object. For all these things, yes, we all know that. I think that is a word which is going nearby. Yes, that is nothing but the force. So in a dynamics, mainly we'll be talking about the force, because that is the main reason for the motion of an objects. As a body is trying to move, children, what is that one more thing which is try to stop the motion of an object, which always opposes, children? Yes, that is what actually? Inertia. Is it clear? So mostly we'll be talking about in a dynamics, what is a force, force related, inertia, the combined effects of force and inertia we'll be talking. But we are not going to discuss about the entire mechanics, children. So here in the mechanics, just we have a part, a small part, kinematics only, just we will be discussing. And as we are discussing, about a motion kinematics, children. So here motion means, here we have three types of motions. Of course, many are there, but according to the kinematics, according to our discussion, I am telling you, children, we have a motion one dimension, motion two dimension, motion three dimension. Then what is this motion one dimension, children? It's very simple. If any object is going along a straight line path, I mean what here? Either x coordinate or y coordinate or z coordinate only changes. Such a motion is called, means only one parameter can change, either along x or y or z. Such a motion is called motion in one dimension or linear motion or rectilinear motion. Example, the bodies which are going along a straight line path all comes under this. For example, if here is a marker is there, if I leave this, it will, yes, it will be falling along a straight line path. Yes, this is a one dimensional motion only. Clear? Fine. So next come to the children is a motion in 2D. Means if any objects are moving in a plane such a way that either, children, xy coordinates or yz coordinates or zx coordinates. Children, here only either x or y or z only changes. But here either xy or yz or zx coordinates change. So example, children, yes, under this motion 2D only, we will be studying about the projectile motion and the circular motion. Children, those topics are very important for an examination point of either for a NEET or a mains. Okay, fine. So this is along a straight line path. This is motion in a plane, children. If any object is going in a plane, comes under motion in 2D. Then comes the motion 3D. So the motion in which x, y, z, three parameters will change. So example, the objects or particles moving in a space comes under motion in 3D. For this, then what can we give example? Yes, children. Here the motion of a molecules of a gas, children. Yes, we'll be studying in a kinetic theory of gases. Yes, molecules will be moving. Okay, they will be moving randomly. As they are moving, x, y, z coordinates will be changing. Even you can take a one insect which is moving in a space, any object which is moving in a space, all comes under what, children? It's a motion in 3D. But here we are not going to continue right now motion 3D or motion 2D. We are going to continue about the motion in 1D and the related concepts. Later we will discuss about the motion 2D, where we will be talking about the projectile motion and circular motion. Actually, now we try to understand two more important, what we can say, words which are very important to us for all our understanding and for all our measurements. To have better understanding about that, actually, look at here, children. Here two persons, they are going to Delhi in a car or any vehicle, let us say that. So whenever we are going to any particular place, children, so generally the talk comes, okay, na, when that particular place or when that particular station comes. So like that only let us say the person B is asking person A, dear person A, could you please tell when that Delhi comes? Then he may say, sir, after 5 hours. Again he may ask after 4 hours, after 3 hours. Okay, I don't find any fault in that talk, but I have a doubt actually. The person asked when Delhi comes, and he says that he says that yes, Delhi comes in 3 hours, Delhi comes in 2 hours. But my question is that, is the Delhi coming towards these persons, or these persons are going towards Delhi? So if you can see, actually in general, the Delhi is there only. Delhi won't move from there. Either a Delhi railway station, Delhi bus station or anything, whatever it may be. Delhi won't move, right? Only the persons are moving. But why they are talking like this? Not only these two persons, children. Whenever we make a talk actually like this, what we do, we assume that we are at rest. We assume that we are at rest actually, and other things are in motion. Okay, means here, let us say that this is a person B is observing all these things. Okay, means he is measuring the distance between the Delhi and this car from his compartment, so-called car only. For that, he is observing that yes, he is at rest in the car, so that he feels that Delhi is moving. In fact, when you are traveling in a bus, even railway station also, you can notice that you will be telling, hey, this station is going, trees are, you feel like trains are going, objects are going, some houses are going, some stations are going. In fact, they are not going. You are going, right? But why are you feeling like that? Why are we thinking like that? Why are we talking like that? Because we are assuming that we are in rest. We are assuming that we are in rest, and from that point only, from that particular plane where we are sitting, from there only we are noticing all other objects. As we are assuming that we are at rest, obviously other things will be in motion. So children, the plane or the place from where all observations are made is called frame of reference. Children, it's very, very, very important. What is that called, children? It's a frame of reference. Very, very, very important. Frame of reference. What is the frame of reference, children? Yes, the point or the plane from where observations are taken are called frame of reference. The person who is taking the observations is called observer. So for us, observer is very, very important. So again I'm telling you, so means here what is happening here, every person who is observing this frame of reference, yes, he is assuming that he is at rest and he is noticing the things. Okay, fine. So in our physics, children, so we take a Cartesian coordinate system as a frame of reference. Cartesian coordinate system we use for this purpose. But can we say only the Cartesian coordinate system x, y, z, let us say it's x, it's y, z, just called a frame of reference, children? No. This Cartesian coordinate system where the person is sitting, is assuming that he is sitting, plus clock, very, very important, clock, why? Yes, to measure the even time also. Means from this frame of reference, children, we can measure x coordinate, y coordinate, z coordinate plus even time also. So these coordinates plus time along with observer, okay na, is called frame of reference. The point where the particular sitting, usually we assume that observer is sitting at the origin. So it is, means we assume that the person is sitting at the point where these axes are meeting, so called origin actually. So children, I repeat once. So Cartesian coordinate system plus time we can take as a frame of reference, and with respect to that only we will be taking the values to make our calculations easy, so that we can understand the concepts related to the kinematics. The simple terms, children, frame of reference means what? Children, there is no particular thing in our constitution to say that this is only called a frame of reference. It is not like that. From wherever you are observing, from wherever you are taking the observation, that particular place only we can call a frame of reference. For example, you are in a boat observing the things. Yes, your boat is a frame of reference. Or you are sitting on the tree and you are noticing the things. Yes, the tree is what you can say, a frame of reference. You are sitting in a car going in a particular place. Yes, your car is a frame of reference. You are on moon. From there you are taking observations. Moon is a frame of reference. But usually we don't go to moon to take all these values, right? So usually we stick to the Earth surface. Usually, in general, I am taking, not in a special case. In general, okay. You are sitting in your house, children. Right now, you are sitting in your house and listening to my class. Okay, and from there you are observing your surroundings. Yes, your house, your particular place, the bed or the chair where you are sitting is a frame of reference. Hope it's clear? Yes, children. And here, for suppose here, let us say here is at a point A. Okay, na. Here the person B is there. Person B. Okay, na. So the distance, he says that. Okay, let us say that it is one more place. There are two places. So A and B. Okay, na. Here one person X. Okay, na. He says that yes, this particular place is at a 5 kilometer distance. But is it true? Is it true? You may get 1 dot. Yes, sir, it might be, it's true, right? You can measure and you will get. Okay. For example, one more person Y is standing here. He says that 10 kilometers, same place. One more person is here, let us say Z person. He says that it is a 2 kilometers. Then who is right, children? Yes, all are right only. All are right only. That's what. So they are talking, they are thinking from their point of view. So for this person, here is the origin. For this person, this is the origin. For this person, this is the origin. So which means what? It varies from person to person. It varies from observer to observer. This is what actually we have to notice. Children, the values, the measurements, whatever we are taking, whatever we are doing is with respect to a particular person, with respect to a particular point of reference. Otherwise, there will be so much of confusion. So, whenever we are taking the values, children, yes, that's what I said. We need a frame of reference from where we are taking the observations. It's a very, very important. Clear? Fine. Now, we need to talk about one more word called a position. So, position means what actually, children, here? So, position means, sir, my position is like this in a society. So, my parents' position is like this. So, I am not talking about that position. The word which is related to our discussion of talking. So, what do you think is the position, children? So, simply it is a position means what actually? Location of an object with respect to the observer. So, it's very, very important. So, again telling it's a respect to the observer, location of an object with respect to the observer, children. So, here this position can be, okay, so here 2 we have. This position can change with time, position can change with time, position can change with time and cannot change with the time, can change with the time, cannot change with the time, children. So, if any object again with respect to the observer, so called with respect to the surroundings, if it is not changing its position, then only we can say that, so it's not changing position, we can say that that particular body is at rest. Whereas if it's changing its position with respect to the surroundings, with respect to the observer, with respect to the frame of reference, we can call that particular body is in motion. Particular body is in motion. Children, here again it's a respect to only. There is no absolute rest, there is no absolute motion in this universe. This here, motion and rest, these are relative. Very important. These are just relative only. So, relative words, okay, you cannot say that the particular object is 100% at rest or 100% in motion. Purely depends on the observer. Purely depends on the observer. So, let us take that. Here, 2 persons A and B already have taken. Let us take here one tree is there. Let us say here one more person is standing. Let us say C. Children, with respect to person B, this person A is at rest. Person A is at rest. But whereas with respect to this person C, this person A is in motion. Then who is right? Person A or person C? Both are right only. That's what I am telling you. The point from where you are noticing is very important. The location is very important. The frame of reference is very important. This person B, if he thinks about person A, he assumes this person B at rest. Then with respect to this person B, the person A is in rest only. But when you are talking in terms of person C, children, yes, he is assuming that he is at rest. Okay, from his frame of reference, he is thinking. So, rest and motion, these are what, children? These are purely relative terms. There is no absolute rest, there is no absolute motion. Children, let us assume that body is coming to motion. Just somehow, see, you cannot ask, you cannot think what is the reason why the body is coming to motion. So, very clearly I told you that in kinematics, we are not going to talk about the cause, we are not going to talk about the reason for motion. Just blindly we assume that yes, object is moving. We don't know why all these things. So, object is moving, children. For suppose if object comes into a motion, so here there are 2 important parameters which come into play immediately, children. So, which are very important to discuss. So, those 2 words are, children, here is distance. Those 2 words are distance and displacement. Distance and displacement. So these two terms, the moment the body comes into motion, children, yes. So these are the two parameters about which we have to discuss, distance and displacement. Children, it's very simple. I think from in the 6th class, 7th class, 8th, 9th, 10th, yes, you have been studying about this. Yes, let us recall about this so that to get a good command on the next coming topics. For suppose, children, so what I mean to say that here, for suppose you are going to take a just assume that you have taken admission in some X college. You have taken admission in X college. Okay, you are new to that area. Let us say that you ask your friend. Oh, you ask your friend, someone, some X person you asked, where is that particular X college? Okay, he says that yes, it's a 5 kilometers from your house. Okay, let us say that this is your house, children. It is your house. 5 kilometers means like this you can go 5 kilometers. Like this you can go 5 kilometers. Okay, like this also you can go 5 kilometers only. But you are not sure that you will reach your destination, right? So whatever, children, do you think that with this information you are able to find the location? So it's not 100% possible, right? Okay, luck, unless there is a luck. Okay, that luck just you keep aside, then it is not possible because 360 degrees or 5 kilometers will be there. So whatever your friend gave you that information 5 kilometers only, we can call it as a distance actually. Because for a distance, to describe a distance, children, direction is not required. But if you want to find that particular location, means distance will simply tell how far that location is. But whereas when you were talking about the displacement, children, how far and where means what? Direction also important. So this here distance will tell you how far, very simple. It will tell you how far. Whereas displacement will tell you here how far plus where it is. That is direction also. Direction also. So here direction is not required. So here distance is a scalar quantity. The quantity which requires only magnitude but doesn't depend on the direction. But whereas here displacement is a vector quantity. So it should have a magnitude and as well as direction and also should obey the law of vector addition. Should obey the law of vector addition. Clear, children? Fine. And here one more point, let us talk about this. So it is a how far and here is a how far plus direction and it is a scalar and is a vector, children. Now, okay, now you came to know that yes, that particular college in some particular direction. So it is your house. Okay, let us say that this is your college. So first day somehow you went like this. In this part, okay, like this you went. Let us say it's a 5 kilometers. You are going and coming, you are going coming. So after few days, children. So generally whenever you are going to particular places, we'll try to search some shortcuts. What do you say? Yes. So after some time, after few days, you realize that yes, you can go like this, which is of like 3 kilometers. 3 kilometers. And you got after few days, you got a best buddy who shows you the best path. Let us say that, so that you can reach. Yes, this is the. This is so. Let us say it's some 1.5 kilometers. So let us say it's the first path, and it is the second path, and a third path, children. So in these 3 paths, children, which will represent a distance? Yes, 3 will represent a distance only. First of all, what is the distance, children? The length of the path covered by an object is called a distance. The total length of the path covered by an object is called distance. For suppose if you are going along the first path, yes, your distance will be 5 kilometers. If you are going along a second path, your distance covered is 3 kilometers. If you are going in the third path, your distance is 1.5 kilometers, which means what here? 1, 2, 3. This 3 will represent a distance only, children. This 3 will represent distance only, which means what here? Here distance depends on the path, children. It's very, very important. So distance depends on path. Distance depends on path. But whereas what can you say about a displacement, children? Yes, I can say only this path, sorry, not one. So let us say the third path only I can say it is a displacement. Third path is displacement. So why not 2 and 3? So what is the displacement, children? So the displacement is the path or the distance between initial and final points. Let us say it's like a shortcut. It is like you can't say distance between the 2 points, children. You must mention that it is a smallest distance, the smallest length between initial and final points in a particular direction is called a displacement. So which means what here? This displacement does not depend on first path or second path, third path. It depends only from where you are starting, from where you are reaching. So which means what? It depends on, so displacements depends on initial and final points. Initial and final points. Is that clear, children? Fine. So as it depends on initial and final points, now let us see this point. This is going to be a very, very interesting. So for suppose, children, so you are at a point A, you want to go to point B. Okay, so let us say that that first, what is the third path? Okay, daily you got to know that the shortcut so that you are following the displacement, so that you can just cover 1.5 kilometers displacement to reach your college. Let us say that. Okay, you are going from here to here like this, A to B, like this you went like this, from A to B you went, children. So in this case A to B, what is the displacement? 1.5 kilometers only. Okay, what is the distance? 1.5 kilometers only. Yes, is it possible to have a distance and a displacement same values? Yes, it is possible, children. So whenever bodies are going along a straight line path, children, yes, distance can be equal to displacement. So here I am putting an arrow mark to show that yes, it is a displacement has a direction, it is a vector. So distance can be equal to displacement when only when the bodies are going along a straight line path. Okay, fine, children. Now okay, after that you are again from point B to, okay, you are coming to like this. As you are coming to like this, let us say that, okay, you came to this point, let us say that point C, point D, you are reaching like this, let us say that. Now you reached even point E also. Okay, children, from A to B if you are going, it's a distance and displacement both are increasing till here is a maximum distance and displacement 5 kilometers. But when you are coming back, children, yes, your distance is increasing but not displacement. Displacement is decreasing. You may get one doubt, sir, how it is possible? Yes, children, distance is what? The total length of the path covered. Let us say you have to calculate this entire path also we have to cover. Okay, na? But what about displacement, children? Displacement depends on initial and final points only. As I told you, that depends on only initial and final points only. So here, for example, let us say you reached here, then you should take this only, right? So this will be the displacement. If you reach here, this will be the displacement. So which means what here? Distance can increase with the time, children. Increase with the time. Distance can increase with the time. Whereas displacement can decrease with the time. Yes, it is possible. Decrease with the time. Decrease with the time. The moment once the body set into the motion, children, yes, distance have some value. 100% distance have value. Distance has a value. But displacement can be zero. Though the body is in motion, still displacement can be zero. How it is possible? Yes, look at here, children. Look at here. So for suppose here you are coming here like this. For suppose point A to point B, as I told you that it's a from here to here is a 1.5 kilometers. 1.5 kilometers. Now again you reached point B only, let us suppose. Point B only again you reached. Means A to B to again A only. Then your distance can be 1.5 plus 1.5 is a 3 kilometer. But displacement can be 0. Why? Children, usually right side we can take as a positive, left side we can take as a negative, because displacement is a vector quantity. So plus 1.5 minus 1.5, it's a 0, which means what? If a body is reaching again back to its initial position, the displacement covered is 0. Displacement covered is 0. So displacement can be 0, but distance can never be 0. Distance can never be 0. And moreover, children, between 2 points, how many values are possible for a distance? can be infinity, because you can take in any path, so you can have infinite what we can say values for a distance between a two initial and final points. But whereas for a displacement, only one value is possible. So with this, it's very clear that yes, displacement can be 0 even. Let us take one more point here. So here is, so A to B. As I told you that right side we are assuming like a, positive children. So the body has covered A to B, let us say 1.5 kilometers. Okay. Again from here B to A, like this only, it went to C, let us say that. It went to, okay, somewhat like this it went. Okay, let us say this point is origin. Okay, so A to B is 1.5 kilometers. Let us say A to C is like, for example, children, 4 kilometers. Okay, now this will be a plus, this will be a minus. If I want a total displacement, children, minus 4 kilometers plus 1.5 kilometers, then distance can be minus 2.5 kilometers. Children, what is the distance? Yes, distance is 1.5 plus 4, it is a 5.5 kilometers. So here what we can conclude? Yes, so distance is always positive, children, but displacement can be negative. So here displacement can be 0, displacement can be positive, displacement can be negative, but whereas distance is always negative only. These are the points which we have to remember about this. Okay, children, fine. So in our example, even in our example, if we can notice, children, so in this case here, distance is greater than the displacement. Okay, and when a bodies are going along a straight line path, we got to know that distance can be equal to displacement. So with this we can come to one conclusion that, children, it's very important, distance is greater than or equal to displacement. Always it is possible. Displacement. So distance either greater than the displacement or equal to displacement, but displacement can never be greater than that of the distance. Is it clear, children? Fine. So these are the points regarding the distance and displacement. Now we see a few numericals to have better understanding about distance and displacement. Just copy this so that we'll go to next point. Copied. 3, 2, 1. Let us say each side is A. Here is A and each side is a K. Actually, in these 3 examples, okay, let us try to calculate the distance, displacement, if possible their ratio. Let us try to, simple one to understand the basic how we can calculate distance and displacement. Okay, children, fine. In the first case, let us say square, children, whose sides are A. Let us say that the particle or a person is starting from A, B, let us say, he reaches a point C. So A, B, C, this A, B, C is what, children? Actual length of the path covered. So here, if you want a distance, children, so what you have to do? AB plus BC, that is A plus A, that you will get a 2A, that's fine. But what about displacement? Displacement is all about the initial and the final positions. What is the distance in a particular direction between the initial and the final position. So here AC, this we have to calculate. So here displacement is what, children? Is the AC. So how can we calculate? Yes, ABC is the right angle triangle. Let us use the Pythagoras theory. Children, AC is equal to square root of AB square plus BC square. So this can be here A square plus A square, that is a 2A square. So here displacement is root 2A. So if you want the ratio, children, distance to displacement, this is 2A by root 2A. A cancel. 2 can be written as root 2 into root 2. So here it is root 2 into root 2 by root 2, children, it can be cancelled. So distance by displacement, distance is to displacement is equal to root 2 is to 1. So in exam sometimes they may ask displacement to distance, then it will become 1 is to root 2. Okay, fine. In the second numerical, if you can, children, here a body is going along a semicircular path. Let us say A, B, C. Let us say A, B, C. Now the distance, children, the distance is what actually? This actually the total, if you can, is like a circumference of circle, but here half of the circumference of circle. Circumference of circle is a 2 pi r, but the half semicircle, right? So 2 pi r by 2 is how much, children? It's a pi r. Then what about the displacement here? Yes, displacement is what actually? Yes, so the shortest length between a initial and a final position, A to C. Children, here let us say O. Okay, na? So you can write as a AO plus OC. AO also it's a radius only. So it is a R plus R. So it is a 2R. Now the ratio of distance and the displacement is, children, it is a pi R by 2R. R cancel. So this is a pi by 2. Oh, is that clear? Fine. Now come to the third one, children. Yes, let us say there is a particular room. Okay, it's like a room. It's like a, it's a cube type shape it is. Okay. Let us say that, children, here one insect. So it is, let us say one insect. So it is not R. Let us say it is an insect only. It is starting from A and here it is going like this towards B, and B to C and C to D traveled. Children, this is the path along which it traveled. So for sake of to avoid the confusion only, other sides I make like a dotted line, so that only your concentration should be on the path along which the insect is going. Okay, fine. A, B, C. Okay, that's fine. Now here distance is equal to what, children? The total length of the path covered. AB plus BC plus CD. So this is A plus A plus A. So this is nothing but 3A. As simple as that. Okay. Then what about displacement? Children, displacement is the shortest path between initial and final points in a particular direction. So now you have to AD, you have to, or AD you have to. Children, AD, don't think they are like a diagonal. It's like a diagonal. AD is a diagonal to the room. Children, now where you are sitting in a particular room, please imagine a diagonal, children. That diagonal gives you the displacement covered by that particular insect. But how to calculate? Yes, so let us use a simple mathematics. Of course, this can be solved by using a vector concept also, but we are not going to involve vector concept here. Look at here. First, I want to find this, children. Look at here. Let us say E. Children, what will be E, children? So this is A, this is A. Okay. So this EA is, see, actually this is A, B. E will be like this. If you can have a top view, A. It is A, it is A. So obviously, children, this is going to what, children? This is going to what? It's like a diagonal, it's a root 2A. So this is root 2A. A is root 2A. Okay, now this, whatever we got AE. You may get one doubt, sir, we want actually AD, right? Why are you talking about this? Children, I am coming to that point only. Now here we got AE like this. Okay, now try to understand. And this is what? This is what actually? Children, try to understand AE. So this is AE, sorry, this is AE, root 2 A we got actually. Okay, now this, we know this, right? This, how much it is? A. So this is root 2A got, this is A we got. Now AD is nothing but the hypotenuse of this right angle triangle. Right angle triangle, try to understand, children. So we can make like this. So it is a E, and it is a D. Children, this is A already, and just we calculated what we can say AE as a root 2A. Now what we want? AD we want. AD is nothing but, children, it's a hypotenuse. Now here you can use a right angle triangle concept. Okay, so here AD is equal to square root of AE square plus D square. Children, so this is going to be root 2A square will be, root 2A whole square will be 2A square plus A square. Children, this is going to be 3A square. So here AD is root 3A. So here displacement is how much? It is a root 3A. Now you can find the ratio. How can you find the ratio, children? Yes, look at here. So the ratio of distance to the displacement is equal to 3A by root 3A. A cancel. This 3 can be written as root 3 into root 3 by root 3. Both will get cancelled. So the ratio of distance to the displacement is equal to root 3 by 1, or root 3 is to 1 actually. Okay, just copy this. Two more important numericals are there. If a body is going along a circular path, children, so the angle made from its initial point will be changing. Let us say 10 degree, 20, 30, 40, 50, 60. But how to calculate? Okay, it covers, if it covers some an angle theta. So how to cover the displacement? Distance very easy because the total length covered. It's nothing but the length of the arc gives you the distance. But displacement is not like that. So this question is going to be very important. Just copy this. We'll come to that actually. Let us point A and point B. So look at here. So first let us concentrate on the first one, children. So as per this, a person is going along a circular track. Let us say that. So he covered from point A to point C and he stopped here. A to C, just A to C. And whose radius of the circle is, let us say R. Now what is the distance covered, children? So distance covered is, it's a 1/4 of the circumference of the circle. That is 2 pi R by 4. Because 4, 1/4, right? So it is a pi R by 2. This is a distance covered by that particular person. Then what about displacement, children? Displacement means A to C. Yes, we have to take a straight line. The initial to final point. So AC will give you. So AC is nothing but, children, it's the hypotenuse of the right angle triangle. So it's very easy. Again Pythagoras theory only. So it is the sides OA square plus OC square. That is R square plus R square. So 2R square. So it is going to be a root 2R. Root 2R. Yes, you can find the ratio easily. Fine. If you, so it is exactly 90 degrees. Okay. But here if you can see, person reached from A to C such that just the angle suspended is 60 degrees initial to final points. So then we have to calculate this AB. How to calculate? AB is a displacement covered. And here also, children, let us say this one. Let us say the point B. So it's covered 120 degrees. Then how to take the displacement? So children, to have to solve this kind of questions, let us develop a common formula. Let us say it's a shortcut so that you can use that formula to get the answers. So for suppose, children, we'll come back to these two numericals later. For suppose, let us say that same circular track is taken. Of course, you may get one doubt, sir, why have you taken R1 to R2? Welcome. Of course, R1 is equal to R2. Don't get confused, children. So here R1 is equal to R2 is equal to R only. Just for understanding, to make the concept clear, I have taken like that. But both magnitude is same. Direction may not be same. Direction is not same because here. So from this point O, let us say that from this position O. Okay. So OA is position vector. OB is its position vector actually. But what we want? We want displacement. Yes. So from initial point to final point. So this is what actually we are expecting, so-called displacement. Displacement. Children, now it's like a triangle, right? Yes, I want to write here only. Look at here. So this is, write on so O, okay na? A it is, okay? And here is B, it is OA, okay? Now here it is, this is AB is what we want actually. So this is R1, this is R2. This we want AB, actually we want, children. So as per the children, if you can see here, these three, of course, OA is a position vector, OB is a position vector only, AB also. These three are representing the three sides of the triangle. And as per the triangle law of vector addition, children, for suppose here, it is, let us say A, it is B, and it is, let us say it's a C. Okay, now see, if two sides of a triangle, two adjacent, again telling. So if two vectors are representing the two adjacent sides of a triangle taken in the same direction, then the third side, which is taken opposite in the opposite direction, will give you the resultant vector. So as per this, we can write here AB plus BC is equal to AC. So now same concept we are going to use here. OA and AB are taken in the same direction, but OB is taken is what we get opposite direction. So this is a resultant one. So as per that here, OB is equal to, children, OB is equal to OA plus AB. Okay. Now OB is what here? R2. Okay. Is equal to R1 plus AB we want. AB we don't know. So let us write like this here. AB is equal to R2 minus R1. R2 minus R1. Children, here only, yes, it is what actually the subtraction of two vectors. and the resultant vector. And how to take its resultant vector? It's a magnitude of the resultant vector, children. Yes, magnitude of the resultant vector is taken as like this, children. So r1 square plus r2 square minus 2 r1 r2 cos theta. Theta is what, children? The angle between r1 and r2. So this is, it is the angle between r1 and r2. So from here, as we know that r1 is equal to r2, then this will be r square plus r square minus 2r square cos theta. 2r square cos theta. Children, here r square plus r square will be 2r square. So 2r square, here 2r square. We can take a 2r square as a common. So here I need to space this here. AB is equal to, sorry, it's a magnitude, no need to write here vector, this one. So this is going to be a 2r square is taken as a common, 1 minus cos theta. Children, here 1 minus cos theta can be written as 2 sine square theta by 2. Very important relation. This we have to substitute in the place of 1 minus cos theta. Then AB is equal to, children, this will be 2r square into 2 sine square theta by 2. Now this can be written as square root of 2 into 2, 4, right? Anyhow, 2r sine theta by 2 whole square, square root square will get cancelled. So AB is equal to, children, are you able to see? Let me find out. Yes, you are able to see. So here AB is equal to, we got 2r sine theta by 2. Children, this is the displacement required. Children, this is a common formula which you can use for this purpose. Okay, na? So what will be this value, children? The magnitude of the displacement AB is how much? 2r sine theta by 2. Now look at here. If I want to solve this one, come on here. How can I solve? AB is equal to 2r sine theta by 2. Sine, what I hear? Sine, children, 60 by 2. Okay, so it is 2r into sine 60 by 2, sine 30. Children, sine 30 is how much? 1 by 2. 2r into 1 by 2. 2 cancel, the answer is r. That's it. Displacement is r here. But whereas here, children, can you try this? What is the answer for this? Pause the video. Come on, just try. 3, 2, 1. Okay, you can comment answer so that I will look into it. So here, children, AB is equal to, yes, 2r sine 120 by 2, 60. So this is 2r sine 60 root 3 by 2. 2 cancel. So here AB is equal to root 3r. Children, this is how actually we can solve the numericals based on like this. If a body is going in a circular path and it covers some, what we can say, it covers some an angle. Okay, 60, 120, something like this. Okay, children, just copy this. So we do one more numerical and just we might end this session to continue speed and velocity in the next class. Okay, just copy this. And P dash. Children, this is a very important question and it's very nice to understand even concept of displacement, even distance also. Children, as per the question, a wheel of radius r is rolling on a road. Okay, it's rolling. Children, then who is the reason for that rolling? We don't discuss in a kinematics. Okay, because in a kinematics we will be discussing about the motion of an object without knowing the cause, without knowing the reason. Okay, it is rolling. Okay. And they are asking us to calculate what will be the displacement covered for half rotation of what we can say this sphere or a circular disc, whatever so called. Half rotation means what? Actually, let us say that here this point P is here, so it is rotating like this. It is like, see, rotating like this. Again, you may get confused. Rolling. So rolling. So that this P has come to this point. Like this P exactly came like this. Okay. So let us say so O. Children, this is what actually distance alright. Okay, so displacement is what? Initial point to find. This they are asking us to calculate. P dash they are asking us to calculate. Okay, na? So let us say that, children, this is completely diameter. Okay, now so this is go P dash. Oh, sorry, excuse me please. P to P dash. So this we need to calculate. Okay, So anyhow children, what will be this side, this one ma, P2O, what is this children? It covered half only, not full, means half of the circumference. Okay, try to understand. From children, from this total one is how much? This total one is 2 pi r, but this point has come to this point, which means what? Only it has covered only half of the circumference of the circle. So that is 2 pi r by 2 pi r by 2. So this is how much is the pi r. It's a clear pi r only. But how to calculate this pp dash? Yes children. So this diameter is how much children? 2r. Yes, diameter is 2r. So this we know 2r, this we know pi r. Then can't you calculate this hypotenuse? Yes, we can calculate. So here pp dash is equal to square root of pi r whole square plus 2r whole square. So this is going to be pi square r square plus 4r square. Here r square you can take a common, and even you can bring out of this square root also. So r square will become r. So this will be r into square root of pi square plus 4. Children, this will be the displacement. And sometimes in children they might ask this angle. Let this angle is theta. They might ask you us to calculate even theta also. So how to calculate this children? Yes, here we know here tan theta is equal to OP dash by OP, because opposite side by adjacent side. So here OP dash is what children? OP dash is 2r and OP is what? Pi r. So r cancel. So tan theta is equal to 2 by pi, and theta is equal to tan inverse it is 2 by pi. Okay children, so these are the few very simple numericals so related to the distance and displacement. Children, as it is a very first day of our kinematics, just the basic concepts, of course you might have studied in our previous classes, 8th, 9th, 10th children, just it is like a recall. So what I mean to say is that without knowing the concepts, the basic concepts, don't directly jump into the numericals. So many students, nowadays I have seen children already at the back of numericals, whether AEEE students or it's a main student or a NEET student, who it is, numerical, physics means numericals. Children, it is not like that. Numericals are the applications of the concepts. If you are okay with the concept, then easily you can apply the concept and you can solve the numericals. So from the beginning only, if you are starting your preparation, already you have started also, please don't be at the back of yes, numericals are important, I know that most of the questions are related to the numericals only, but without knowing the concept, how can you solve the numericals children? So get the concepts and solve the numericals, that to related numericals, and you can solve first, then go for depth application oriented numericals, you can go that. Okay children, fine. So in today's class we covered only distance and displacement children. So next upcoming classes will be covering speed, velocity, acceleration, motion under gravity, and equations of motion. So many concepts will be covering children. So be in touch with our channel. So if you are watching first time, children, I forgot to tell you, this is the first video in our channel. So we are expecting all your support. So definitely you like the channel. Children, we are going to work very sincerely for students only, purely for students only. Please like, and if possible share with your friends, and don't forget to subscribe our channel Physics Plaza 2.0. It's only for children of purely mains and a NEET purpose. Okay children, thank you so much, all the very best.